Hello. So in our first lesson, uh, we have seen that what is a signal. What is a signal? We said that signal is physical quantity. Normally, in our case, it may be a voltage or current, or maybe a power that varying according to time. So we call this a time domain signal. Because this because here the time is the independent variable. So we called it a time domain signal. Okay. So we have seen some classification of signal. So we have learned that there are no any standard to classify a signal. We can classify a signal based on several parameters. For example, first we have classified the signal based on the uh, nature of the time, variable, independent variable. Okay, so here if the time is continuous, we called it continuous time signal. If the time is discrete, we called it discrete time signal. And also we have classified a signal based on it continuity. Okay, we said that repetitive signals we called as periodic signal, and we have discussed one condition to be periodic, that is x t plus t is equal to xt. Okay. So this capital T is the period of the signal. Okay, and okay, basically we have discussed these things in our first tutorial, lecture. Okay, so today actually we have several class of signal, type of signals, random and deterministic signal, then odd and even signal, and energy and power signal, so on. Okay, so we have several type of signal. Okay, so we have to discuss these things. Okay, but maybe this and this one can come to your exams, but we will leave this later to discuss these topics. These topics are under signal classification. Okay, but just now I have shifted this to mainly this two type of signal. Okay, and today I am hoping to discuss some basic signals. So we can say that these are standard signal. Okay. Under basic signals, we are often coming across what is called sinusoidal signal, sinusoidal signal, and also complex exponential signal, complex exponential signal. So today we will see what is a sinusoidal signal. Okay, so I think you already know. Okay. So you know that the commercial power available in Sri Lanka, no? Available in Sri Lanka. So the main provider is the CB, Ceylon Electricity Board. So yeah, I think you know that we call this AC current. We will get from the commercial from the CB. It is a AC current. We call this AC current, and normally it is specified as 50 hertz. 50 hertz. Normally to 30 volt. These are the specification for commercial power provided by CB for home. Okay, so this current, the AC means it is alternative current. That means the polarization of the voltage is changing. Okay, and we call this type of current or voltage is a sinusoidal signal. Okay, so this is one example. Actually, here I got one example for sinusoidal signal. Okay, sinusoidal signal. Okay, this is one example for sinusoidal signal. That is the current or the commercial power we we are getting from Ceylon Electricity Board. Okay, so this is a type of alternative current, and the polarization is changing like this. Okay, like this. So this is basically a sinusoidal signal. Okay, so that means here it may be a voltage or current. Okay, normally it is a voltage. Okay, voltage measured by volt. Okay, and this is time. Okay, and so that voltage is changing according to the time like this. Okay, like this. So this is called a sinusoidal signal. Okay, so there are actually these sinusoidal signals are very important because most often we have to come across these type of signals. Um, another example, this is one example for sinusoidal signal, and another example, okay, for sinusoidal signal is a RF signal. RF signal. So RF signal means radio frequency signal. So if you want to transmit a signal through an antenna, okay, through an antenna, uh, you have to uh, convert it to RF frequency. Okay, otherwise this antenna size will be very large. Okay, so sometime, not sometime, we have to convert our information signal into a RF signal. So in many cases, this RF signal is a sinusoidal signal. Okay, this RF signal is a sinusoidal signal. So it is like this. Okay, it is like this. Okay, and so it may be also voltage with respect to time. Okay, so that voltage with respect to time is changing like this. Okay, so this is another example for sinusoidal signals used in practical system. Okay, so so there are many practical cases. Okay, we are using sinusoidal signal in many practical cases. In many practical cases, okay, cases we are using sinusoidal signal like the voltage or power provided by CEB or uh, uh, the and also for communication, RF communication, microwave communication, we are using sinusoidal signals. Okay, so in many practical cases, we are using sinusoidal signal, and uh, for almost all uh, analyzing part. Okay, almost all analyzing parts. Okay, for many analyzing analytical uh, purposes. Okay, analytical purposes, we are only using sinusoidal signal for simplicity. Okay, so the sinusoidal signals are very important. Okay, so we will see what is a sinusoidal signal. Okay, so I will explain you. Uh, so it is very important to have an idea about the sinusoidal signal. Okay, so if I uh, consider this kind of circle. Okay, so say this is a circle. Okay, so it is not look like a circle, but just assume that it is a circle. Okay, so I have divided this circle into half like this and into half again like this. Okay, so we call this, I think you can remember that we call this line as a diameter. No? This is a diameter. From here to here, it is a diameter, and here to here, it is another diameter. Okay, and half of the diameter we called it as radius. Okay, half of a diameter we called as radius. Let's say that radius of this circle is a. Okay, so so, so this is a radius of this circle. Let's say it is a. Okay, and if I draw a line perpendicular to this circle, okay, ලම්බකව ලම්බකරේඛාවක් ගැහුවොත් මෙන්න මේ diameter එකට perpendicular line from this point. So say this is a point. Okay, this is a point. Okay, let's put it P. Okay, so if I put a perpendicular line here, okay, so if I get this angle as theta, okay, angle as theta, is theta, like this, and this angle is theta. Okay, so let's say this length from here to here, this perpendicular line is y. So if I draw a parallel line to this, from this point to this diameter, then this length also y. No? This length is also y. If this one and this one parallel, okay, so it is a rectangle. Okay, so this this line and this line will be in same length. Okay, so this also y. Okay, so we know that if this is theta, we know that by definition, sine theta, okay, is equal to y by a. Okay, so this mark I put to represent by definition. Okay, this is for definition. Okay, so we know that sine theta is equal to y by a. So, uh, so what happens if theta is equal to 0? Okay, so you can see that if this theta is equal to 0, that means this theta is closer to here, no? Very much closer to here, and this a will come exactly onto this section, no? Okay, so this y will be 0. So if the theta is equal to, you can see that y is also 0, then sine theta is equal to y by a. Okay, and this y is equal to 0, that means sine theta is also 0. Okay, and what happens if this theta is, if this point is come to here, this point is come to here, so first time we call this point is here, no? This point is here, this point is here at this point, this location. This point is in this location. At that time, theta is equal to 0, then y is equal to 0, then sine theta is equal to 0. Okay, if this point is here at this location, that means this theta is equal to 5 by 2. Okay, so this theta is equal to 5 by 2. So, so what is the y value? That means this p is here. That means this y is increasing, 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 and exactly come upon this. No? So at theta is equal to 5 by 2. Okay, so y, this y will be equal to a. Okay, so sine, so here sine 0 is 0. Sorry, this is not theta. This is 0. Okay, this is 0. Then sine 5 by 2 is equal to, now y is equal to a, y by a. So y is equal to a and a by a. So sine 5 by 2 is equal to 1. Okay, so you can see that. Okay, so this y, okay, so by this definition, by this definition, we can say that y is equal to a into sine theta. No? By this definition, we can just multiply the this side, we can multiply by a, then it is y is equal to a sine theta. Okay, so you can see that this is some kind of a function. No? So this theta, let's take as an independent variable. Independent variable. Okay, so this y, let's take as a dependent variable. Dependent variable. Dependent variable. Okay, so you can see that when this theta is changing, okay, that means this point is go along through this circle. Okay, so this point, this p, this point is go along through this circle like this. This theta is changing. Okay, so if this circle, if this point is go along this circle like this, okay, like this, that means the theta is changing. No, this theta is changing, and according to the theta, this y is changing. And what is this y? Actually, it is the projection of this point in this angle, no, in this axis. Okay, projection of this point, projection of this point in this axis. Okay, So it is the y. Okay, so you can see that when, so now I am getting, so you know how to go a function. Okay, we have learned them in our level maths. Okay, so we know that. So we normally draw two lines, no, like this. You already know that. So our independent variable is theta, this, and our dependent variable is y. Okay, so let's say that this theta, we start with 0. That means this p now in this point. This is the p point. Okay, point of p. Now the theta is equal to 0. Then this sine theta also equal to 0. That means sine theta also equal to 0. Then y is equal to 0. No? So you know that I will write it here. Okay. So you know that y is equal to sine theta, a sine theta. Now we get theta as 0. Theta is equal to 0. That means sine theta is equal to 0. We have seen it here. Okay, sine theta, sine 0 is equal to 0. Then y is equal to 0. Let's say it is y1. Okay, so y1 at theta is equal to 0, y1 is equal to 0, y is equal to 0. So this is the point. Okay. So let's say some value here. Okay, so let's say some value here. P is now here. Okay, so theta has some value. Okay, theta has some value. Let's say it is 45 or something. So the theta angle 45. Okay, so you know that uh, this 45. So you know that angle. Okay, angle in degree can be converted to radians. No, can be converted to radians. So how we can we know the relationship. Okay, so we know that 360 degree is equal to 25 radians. No? 25 radians. So we know that 180 degree is equal to 5 radians. Okay, so 45 degree is equal to 5 by 4 radians. Okay, so if this theta is 5 by 4, okay, so that is y is equal to a sine 5 by 4. Okay, so some value is here. So what is this value? Okay, so this value multiplied by this a, you will get this length. No, you will get this length at theta is equal to 45, 5 by 4. Okay, so you will get some value here. So you can mark that value like this. So likewise, you can mark some value like this. Okay, then what happen if theta is equal to 5 by 2? So we will get theta is equal to 5 by 2. Okay, now theta is equal to 5 by 2. So what is the value? 5 by 2. 5 by 2, the theta is sine 5 by 2 is equal to 1. Okay, so here a sine 5 by 2, that means sine 5 by 2 is equal to 1. Then y is equal to a. No? So at this point, y is equal to a. Okay, please try to understand. So if you have a question, you can ask. Okay, so 5 by 2, we will have this point. Okay, then what happened? This point is further traveling here. This point is, so now this point is up here. Okay, so this is now the point. Okay, this point now came to this point, this section. At this time, y is equal to a. Okay, this y will become a. Okay, so this y from 0 to a increasing. No, when this point is traveling from here to here, this y is increasing. So I will draw another circle here to have a better understanding. Okay. So now we started the point here. At that time, y is 0. Okay. Now point is traveling here up to here. So at this time, there is a one distance for y, and this time there is a one distance for time. Okay. So when this point is traveling up to here, you can see that this y is increasing up to this point, up to a. Okay. So now it is up to here. Okay. Now what happened? This p is coming to this side again, this side. That means this p is coming to this time. So projection is now, if the p is here, projection is here. Y is in decreasing. And if the point is here, the projection is here. Again, y is decreasing from here to here. So you can see that when the point is traveling from here to here, y is increasing. Okay. And the point is traveling to here, then y is decreasing up to here. Okay. So you can see that now y is decreasing like this. Okay. Now it at first time from here to here, that is quarter of circle. No, quarter of circle. Circle එකෙන් හතරෙන් එකක්. y මෙතන point එක මෙතන ඉඳන් මෙතෙන්ට යනකොට y වැඩි වෙනවා. Right? So y is increasing. Then another quarter of circle. ආපහු මේ රවුමෙන් කාලක් යනකොට මේ y decrease වුණා, අඩු වෙලා මෙතෙන්ට එනකොට හරියටම y වලගේ බිඳුව වුණා. A point එකේදී y වලගේ බිඳුව. So at this point y is equal to 0. Okay. So what is the theta value here? So theta is increasing here, and again it is increasing, no? Up to here. So this is, it is 5/2. Now it is maybe 100. Okay, maybe 130. Now up to this it is 180. No, 180 degree. 180 degree means 5 radian 5. So if I plot that according to 5, so here it will be 5. Theta is equal to 5. Okay. And what happened if this point is again traveling up to here? So you can see that y is increasing to this side. So at that time, the one is increasing to this direction. We say that that direction is a plus direction. Okay. So now y is increasing in this direction. Okay. So if this is a plus direction, normally in mathematics we can define this direction. Okay. So this is the reference point. Okay. From this reference point to this direction, this distance, we measured in plus. Okay, we consider is a plus direction. So other side, the opposite side, we have to consider as minus. So you can see that when this point, this same point, okay, this point is traveling from here to here to here. Okay. Now you can see that if the point is here, the y is like this. And if the point is here, the y is like this. If the point is here, y is exactly on this axis. So you can see that when the point is traveling from here to here, this y is increasing to this direction, that is minus direction. Okay. So you can see that it is direction like this. Okay. So up to here, it is the maximum value it can get. No, that is minus a. No, okay. So this point, this distance from here to here is a minus a. Okay. So we will have minus a here. Okay. Okay. So at this point, so what happened? So what is this angle? Now theta is come to here, y is increasing, and from here to here, y is decreasing. Now what is the theta value here? Theta is here to 5/2. Now here it is 5. And what is the value of theta here? So it is 5 by, so it, here it is from here to here it is 5, and this section 5 by 2. So 5 by 5 by 5 plus 5 by 2. So this total angle will be 3 5 by 2. No, this total angle is 3 5 by 2. So here it is 3 5 by 2. If we called it in degree, it is 270 degree. Okay. So I don't know your maths background. Okay. So anyway, please try to understand this, because this is very important, because in future we have to use this sinusoidal signals many times. Okay. So you should be able to draw a signal. So this is the basic. Okay. So this is 3 pi by 2. And what happened from if this P, this point is traveling from here to here? What happened? So again, this y is reducing to this direction, no? Reducing to this direction. Okay. And at here, it will be exactly again the y is equal to 0. No? At this point, y is equal to 0. So you know that from here to here, again y will come to 0. That means it is decreasing and became to 0 here. Okay. So what is the theta value here? Now theta is traveling one total circle, no, total round. Okay, from here to here. So what is that value? It is 360 degree. No, in other words, it is 25 radians. So this point is 25 radians. So what happens if this theta is again traveling here? So you will get same like this. No, same like this. And again, if another round is go, you will get another like this. Okay. So I think you get the idea. Okay. So if I draw it again, so we will have, we will have, okay, we will have this kind of graph, no? This kind of graph. If we put theta, if we put y with respect to theta, we will get this kind of plot. So here y is equal to a sine theta. Okay, so we will have a here, and we will have minus a here. So this is, we have 5 by 2. This is, we have 5, and this point we will have 3 5 by 2. This point we will have 2 5. Now this point, what is this point? It is 2 5 plus another 5 by 2. That means that means 5 5 by 2. Okay, here it is 5 by 2 plus another 5 by 2. That means 6 5 by 2. That means 3 5. Okay. And here it is 3 5 by another 5 by 2. So this length is 5 by 2. So 3 5 plus 5 by 2, that is 7 5 by 2. And here, what is this point? It is 7 5 by 2 plus another 5 by 2, that is 8 5 by 2, that is 4 5. Okay, so this is 5, this is 2 5, this is 3 5, this is 4 5, this will be 5 5. So if you write, if you go further like this will be 6 5, this will be 7 5, so on. No. So this is theta. Okay, this is a sine wave. Okay, so let's see what is this A. Okay, so this A we called as amplitude. Okay, so this A we called as amplitude. So this A we called as amplitude. Okay, amplitude. So if the amplitude is high, you can see that this circle will be large. No, this amplitude means the radius of the circle. So it will be large. Okay, so that is one parameter. Okay, now now you can see that this when, so I will go it here because now that circle is very unclear. Okay, so this is the same circle. Assume this is the same circle. So I will take this point. Okay, and this is A and this is theta. Okay, so this is the point. Okay, and this will be Y. Okay, so we have plot Y with respect to theta, with respect to theta. Okay, so say that this P, when this P is traveling from here to here, you can see that this theta is changing. No? So this P should be travel along this circle. So let's say that this P is traveling with the constant velocity. ඒ කියන්නේ එකම වේගයකින් travel කරනවා කියලා හිතන්න මේ point එක. හරි? Let's assume that the velocity is omega. Okay? So මේ වේගය අපි හිතමු omega කියලා. Okay? So now this point is traveling with the constant velocity and let's say that is omega. Okay? So that this point, ඒ කියන්නේ මේ point එක කැරකෙන වේගය. කොහොම අපි omega කියලා ගත්තා. So so what happened? Okay, so you can see that if this is omega, okay, so this theta, so now this point is traveling like this omega with a constant velocity. So you know that this theta, so let's say that the point is starting here. Okay, so let's say that point is starting here at the time is equal to 0. So sometime at t time the point is here. No? So what is this distance, traveling distance? It is omega t. Okay, so this distance is omega t. Okay, and that is exactly equal to the theta, no? In radians. Okay, so in other words, we can say that omega t is equal to theta. Okay, that means this theta, now this theta is a function of time. Okay, so you can see that instead of this theta, we can put t here. Okay, now when theta is increasing, okay, this p is traveling along this circle, no? Like this. Okay, this theta is traveling along this circle like this. Okay, like this with the same circle. Okay, so instead of this theta we can put omega t. So here it is t theta. Okay, now so now this so now these are not angle. Okay, so at this point these are not angle, these are time point. Okay, these are some time points. Okay, so so now we try to plot y with respect to t, not theta. Okay, so y is equal to sine theta. You know that. Now we put this theta is equal to omega t. Okay, so this omega is a velocity. Actually, we call this angular velocity. Okay, this is an angular velocity, not a linear velocity. මේක සරල රේඛීය ප්‍රවේගයක් නෙවෙයි, මේක කෝණික ප්‍රවේගයක්. We called it angular velocity. Sometime for more when you are learning for motors and such stuff, you may have learned this concept. Okay, so this is angular velocity. Okay, this is angular velocity. Sometimes we called it angular frequency. Okay, so sometimes we called it as angular frequency. So I will use the both words, angular velocity or angular frequency. Okay, so this is theta is equal to omega t. So now I can say, so this is a sine omega t. So I can write it as a sine omega t. Okay, so you know that when this omega t is equal to 0, this is 0. When this omega t is equal to 5/2. Okay, so we have here, but here not t is equal to 5/2. Please understand that one. This is not t is equal to 5/2, but omega t is equal to 5/2. Then t is equal to 5/2 omega actually here. So this t point is 5/2 omega. Okay, and at this point omega t is equal to 5. That means t is equal to 5 omega. Okay, like this. You can have the same graph like this. Okay, same graph like this. Same graph like this. Okay, and so this point is theta, omega t is equal to 3y/2. Okay, that means here t is equal to 2 omega, 352 omega. Okay, and here it is 25 omega. Here it is 35 omega. Here is 45 omega, like so. Okay, so it is with respect to t. Okay, so you can see that. Okay, that if this is the time, so this time, if we take this total time from here to here, okay, from here to here, that is the time that take to complete one circle, no? ඒක තමයි මේ point එක circle එකක් යන්න ගත වෙන කාලය. හරි? So this section we can say one circle from here to here. So the time take, let's say it is capital T. Okay, so that time is the time take to complete one circle. Okay, so this time is completely time that takes to complete one circle. Okay, so at 1 second, so it will complete 1/t circle. Okay, it complete 1/t circle. This we called as frequency. Okay, so this we called as frequency. That is the frequency f. Okay, that is in another word, number of circle for 1 second. Okay, so for 1 second. So we have here we have learned two concepts. Okay, one is omega, that is angular velocity or angular frequency. And here we have defined another parameter, that is number of circle for 1 second. Okay. So that is we call frequency. Okay. So you can see that. Okay. So you can see that if this omega, this is the velocity, if this omega is high, so to complete 1 circle, it will take very less time. If this omega is very low, that means this point is traveling very slowly from here to here, very slowly. That means it will take much time. Okay. In other words, if this omega is very high, that means number of circle per second will be very high. No? So this omega is very high, this frequency also very high. Number of circles per second also very high. If this omega is very low, that means this point is traveling very slowly from here to here. Okay, that means this f is again, that means number of circle per second will be reducing. Okay, so you can see that we can get direct relationship between this omega and f. So this omega is angular velocity or angular frequency. So this f is frequency. Okay, so what is the relation? So you can see that. Okay, you can see that. So let's say so this so this is omega. Okay, if capital T, okay, if capital T, so this T is the time taken to complete 1 circle. So let's say omega T, that means it complete 1 circle, that means it complete 25 degree, no? 25 degree. 25 radians. Okay, so that means let's say this point P, okay, P will get T capital T times to complete up to here, up to this circle. Okay, so you can see that at capital T, this P is traveling from here to here. That means it traveling 25 degree, no? 25 radians. From here to here, it is 25 radians. Okay, 1 circle. Okay, so you can see that omega T is equal to 25. So you know that omega is equal to 25 1 by T. So what is 1 by T? 1 by T. That is number of circle for 1 second. So that is F, no? So within this, we can define 1 by T is equal to F. So in other words, this is F. Okay. So omega is equal to 25F. So these relationships are very important. So you have to keep remember this. Okay, at least. Okay. So you know that if this is T, okay, this is T. If T, that is time taken to complete 1 cycle, okay, if this is, we call it as actual period, okay, we call this as period, okay. So if this period is T, 1 by T is equal to F, this is one relation, and you know that omega T is equal to theta, this is another relation, okay. So omega capital T is equal to 25, this is another relation. So omega is equal to 25F. This is another relation. So you have to keep remember these 4 relations. Okay. I have explained how this relation derive. Okay, if you couldn't understand it totally, it is okay. At this point, please try to keep remember this uh, relationship, this identity. Okay, so that is one important. So now we can define y is equal to a sine omega t, or y is equal to a sine 2 phi ft. Okay, so this omega is angular frequency or angular velocity. Most probably we called it as angular frequency. Okay, and this f is frequency. Okay, so now our sinusoidal signal we can represent like this. Okay, so now let's uh, so we always now up to this point we assume that the starting point of this p is here. The starting point of this point p is here. That means theta is equal to 0. Theta is equal to 0. This point is starting. Okay, so sometime this point at the starting point, this point may be here at this point. Okay, that means it go to this side by some value. So now the signal is not starting here. Now the signal may be starting from here or here or here, because now theta has a value. Okay, initially theta has a value. So this initial value we called as phase shift. It is another very important parameter, phase shift. Okay, so that is this phase, if this phase shift imply the location of starting, the start location of start of this point. Okay, of this point. Okay. This is another important. So if this if it can be start here, that means now it is in this direction. That means this theta has a negative value. So that means maybe the signal can be start from here like this or something. Okay. So this is the phase shift now. Let's say this theta, it is initial value, not theta. Let's take as 5. Okay. So this 5 is a phase shift starting point. Okay. So now we can introduce the phase shift here. Okay. So now it is y is equal to a sine 2 phi ft plus 5. Okay. So this is the phase shift. And this is the frequency, and this is the amplitude. So these are the most important parameter for sinusoidal signal: amplitude, frequency, and phase shift. Okay, so finally, okay, if you can't understand this stuff, this circle rotating, that type of things, if you couldn't understand, please try to remember these things. Okay, and you have to understand the relationship. Okay, sine 2 phi ft plus 5. This is the sinusoidal wave or sinusoidal signal. Okay, and you know that this A is amplitude, this F is frequency, and this 5 is phase shift. So you have to remember this. And you know that 1 by T is equal to F. So this is the period. In other words, time taken to complete one circle, time for one circle, okay, and omega is equal to 25f, and also omega is equal to omega t is equal to theta. Okay, so you have to understand these, at least these three identity. These are very important. Okay, so you can see that if this f is uh, very high, okay, very high. If this f is low, so frequency is low, that means the circle is rotating very slowly like this. Okay, so to complete one cycle, it take much time. But if this f is high, that means if it is rotating very fastly. Okay, so that means within this time it will complete several circles. Okay, so you can say that when the f is reducing, f is increasing, this period will be reducing. Okay, f is increasing, the period will be reducing. Here we can use this to describe this. If t is increasing, f is decreasing. Okay, so those are the things you should keep in remember. Okay, now I think now it is time to generate some sinusoidal signal in MATLAB and see what happening. So in next tutorial we see it. Okay, so try to go through this lecture and try to understand what is a sinusoidal signal and what are the most important parameters of the sinusoidal signal. Okay, and uh, so as exercise, try to draw this signal with hand. Okay, not using a MATLAB or something. So if we have a signal like this, Vt is equal to 20 sine 2500 t plus 5 by 2, 5 by 3. Okay, so try to draw this signal. This is a voltage signal. Okay, as example, exercise. Try to draw this signal. Okay, and try to calculate the period of the signal. Okay. So as a home exercise, try to do this. In next tutorial, we will discuss this and we will try to generate this signal with MATLAB. Okay, so in next time we will see this. Okay, now please try to do this assignment exercise. Okay, thank you.